Good morning, everyone. This is Gaurav. So, in the last two sessions, we kind of completed till functions. So, now I am starting from classes and object. I would be sharing my screen and also I'm sharing the collapse link. So, you guys can like go to the link and clone that collab notebook and then work on your own. Okay. So, since we are starting with classes and objects, so the first thing would be uh, that what exactly is object-oriented programming. So object-oriented programming is a paradigm which started in 90s. So it was like mainly meant for creating bundles of individual objects which have some particular properties and behaviors which are near to real life scenarios, and we kind of use them in our coding languages. So what it means is that adding up of real life properties of any objects that we can see into a software programming language. So that is what OOP is. OOP is. So OOP consists of classes and objects. So I would be explaining first what exactly objects represents. So let's take an example of a person. Okay. So now I'm creating in a programming language. If I want to create a person, how would I do that? So defining a person in a programming language will lead to creation of an object which consists of a name, age, address. We can add in more. We can add in height, then weight, and more and more. So those are like the properties which you via which you define what the person's properties are. Then you have something known as behaviors, which are like the normal functionalities which a person would be doing, which is like walking, talking, breathing, running, so on and so forth. You can add on sleeping, waking up, and whatever you want. So when I define functions as walking, okay, so what I would be doing is, let's say I add in a running function, like I want the person to walk. So I would be adding in some functions via which I will be defining the person is walking. So that is how an object is defined in software languages. Majorly, like whatever you see in real life scenarios, you are able to like implement that on your language. So via this example, we can see that objects like consist of two major characteristics. One of which is your attributes, which are the properties, which like defines what exactly the person is, and then the other is behavior of that particular object. So behavior in this case would be person's functionalities, which are like these ones. So I have like another example, which is like I'm taken object as parrot. So for parrot, the properties again would be, let's say we can add on name for the parrot, then color of the parrot is a major attribute because like we know that parrots are majorly greens, but then they have other colors also. Then we can add on age, height. So these all are the attributes when we consider parrot as an object. So what exactly would be functionalities of a parrot if we consider it as an object? So parrot would be like it can fly, then it can sing, or like I have added dancing as a functionality, which is also there. So that is how we define, like how we would be saying what an parrot object would be. So this is what object like means and how you can like you can use an analogy to define it in software programming language. So moving on with why we use OOP in Python. So OOP kinds of like, since we are building, I will explain later on like majorly what exactly OOP does. But then in Python, we majorly focus on reusability of the code whenever we see OOP is used in Python. So what we are doing is we are making a smaller code so that we can use it again and again in other library, in other functions or programs which you would be writing later on. So this you would be understanding via the following example. So since I said that object-oriented programming consists of objects, so we would be requiring something which would be defining what exactly the object is like. So that is where your class comes in. So what class is? Class is a blueprint or more like a factory wherein you define what exactly does your objects consist of. So let's say you are defining a class to define Toyota, or let's say any particular car brand. So all the functionalities of that particular car brand, its major looking and features and everything else would be similar. So we let's say that we are currently defining a class of a car, let's say Toyota, and then over the class function you would be defining that the Toyota car consists of tires, let's say, then a particular mileage would be there. It will have a particular style of chairs, like the seating arrangements. Then you can go on with the look of the car. So that is what we like kind of understand from what class. The class would be defining how your object would be looking at the end when you actually use it. So that is what class is used for. So class is like kind of defining what exactly your objects would be looking like. And to define the values to your objects, let's say you are defining a color or number of tires, number of seats, so on and so forth. So that is done in constructor. So what constructor is, it is a part of your class. It is a function which is part of your class wherein you define values to your objects, which you would be defining later on. So hopefully this is understood. If you have any doubts, then you can start it on your. If you have any doubts, you can add that on your Q&A wala part. So moving on, how to actually define like a class in Python. So this is syntax of defining classes in Python. You are supposed to write class, which is a keyword which defines that this particular thing is the name of your class, and after the colon, whatever you would be writing would be defining how the class is supposed to work. So this is your syntax. So over here, I've given an example of defining a car class, and I'm writing pass. So pass is another major keyword in Python, which kind of like helps the interpreter understand that this particular part is supposed to be passed. Like you are not supposed to actually like do anything over there. You're just supposed to skip it. So here is a diagram which explains how exactly pass works. So what happens in pass is whenever you write pass statement, your compiler, as soon as it sees the pass statement, it will do no operation for that particular thing. So if you remember that we explained blocks and functions last time. So in functions, we like in Python, we have indentation defining that this particular thing is part of this particular class or this particular function. If I write like def and then function name. So after this colon, whatever I write in this particular indentation level would be a part of that function. So this pass means whatever is the part of that particular function, we are just supposed to skip it and then move on to the next part. So over here, I'm just like defining a class. So I just wrote pass because I am not sure what exactly I'm supposed to add on over here. So moving on, I would be explaining what class is, which I did earlier. So as you can see, class is a blueprint which is used for defining an object. So if you like relate it to this diagram, so you can understand it from over here that let's say that we are defining a class which is used for defining same type of cars. So that later on you can create many objects of that particular class which is used for defining different types of cars. So over here I have defined the class car. Now I'm defining an object for that particular class. So how do we define objects in classes in Python? Sorry, in Python. So we just write then the object name and then we write equal to the class name and then these brackets. So what this does is it defines that this particular obj is an object which is an instance of this particular class. So what exactly is an object is? Object is an instance of a class which like consists of all the attributes and methods which are defined in the class. So what you can understand from this is that class is a major blueprint and object would be having all the properties or the functionalities which we have defined in the class. So you can create like multiple objects and you have only defined all the values of all the functionalities and all the values in the class function itself. So what will happen is you can see the reusability over here. You have written one class function at the top, and then whenever you define multiple objects, all the objects will have similar functionalities which is defined on the class. So you are not supposed to define it again and again that this particular class has these attributes. You have already defined that over the actual class definition. So over here I have an example defining a car class with some attributes wherein I'm just like adding on the year when it was made, then mpg, and then speed. And I'm defining some methods which is like normal car. What functions would your car have? So the functionalities which car has is acceleration. So I've written accelerate and brake. So currently I'm just defining two of the major functions, which is accelerate and brake. And then I'm defining an object which is car1. So this is like defining a class which is class car, and then I'm defining the attributes value. So I'm defining that year is equal to 2016 and mileage is equal to 20 and the speed of the car is 100. So over here you can see that the car has defined with some particular values which is going to remain same for all the objects which would be created later on. So these are the attributes, more like the normal real life scenarios and programming language. Then moving on to defining the methods. So I'm defining accelerate as a function over here, and I'm writing self inside it. So what self is a keyword in Python which is used for pointing out to the currently calling object. So what this means is if I define car1 is equal to car, right, and then I do car1 dot accelerate. So it kind of explain that uh, we are supposed to return car dot speed plus 20 for this particular car. So that means that the value of the speed is 100 for this particular car1. And what I'm doing over here is I am returning this particular car1 car speed. So I'm not defining, if you see, I'm not defining over here car1. I'm writing car over here. So what that means is via self, we are pointing to car1, and then we are pointing to car1 ka speed, which is 100. And then I'm adding 20 to it. So the only thing when I do accelerate, what I'm doing is I'm adding on speed 20 to what the actual speed was. So over here, first I've invoked the object via defining the name of the object, which is car1, and then the name of the class, which is car, and then invoking it through the brackets. So if I run it, so okay. So as you can see over here, I actually didn't like run this class function. So it gave an error. So first we're supposed to define the car so that we can like relate that this is the particular blueprint for which we are looking at. So car1 is the object of the car, and then when I do accelerate, so it returns the value as 120 because initial speed was 100, then I'm adding 20 to it, so I get the answer as 120. Now let's say we want to check the attributes of the objects, which is like what exactly is the year when the car was launched. So over here I've already predefined the values, right? So I don't like need to add on the values key. I need to change it. So it will directly show that it is 2016. So as we can see, I'm using a dot over here. So what this dot specifies is, so if you see, this is the object, and adding on to a dot, it kind of it will kind of let you use all the attributes and methods which are defined over here. So it will like kind of understand that I need to go for car1, and then I need to check for the class, and inside the class I need to look for this particular attribute or this particular function. So when I read accelerate, so it will go to it will check that car1 is a object of class car, and then inside that I'm looking for function accelerate. So that is what dot is used for. Dot is used for letting the interpreter know that you are kind of looking for this particular value inside this particular class. So, so over here we kind of completed what classes and object is. So I would be moving on to methods. So what methods are? Methods are your normal functions which like we initially defined like last time, which is like def and then writing the function name and then defining the attributes which we are passing and then just doing whatever the functionality which we want to do. So what method is a function which is defined inside your class. So we just name it as method, nothing else. So these are like the behaviors which we are defining that your object would be having. So over this example, I have defined two methods, which is sing and dance. And this particular thing, you can see that I have another function, which is def and then init and then self name and age. So what this is your constructor. So I would be explaining over here what constructor is. For now, just assume it to be a function, a special function in which we are just passing in self name and age. And what I'm doing is I'm doing self dot name is equal to name. So when I create an object, right, like when I create this object for class parrot, blue is an object for class parrot and in which I'm passing two values, which is blue and 10. So when I do this, it will directly invoke this particular method. And over here, as we can see, we have three inputs, self, name, and age. Self is a special keyword which helps the interpreter know the calling object. So what will happen is it will understand that we are using blue over here. So whatever value we are assigning would be like add on to this blue object. So and then we are passing two values, one is blue, another is 10. So this is the name string and then age 10. And then I'm assigning those values which were taken from here to the actual object. So over here, blue will have name as blue and age as 10. So if I run this now, if I like print the value of blue dot name, let's say we want to check out the name. So you can see that it is defined as blue. So if I want to change the name, okay, if I want to say that this particular object needs to have some other name, so I can change it over here and then you can see that it will change it automatically. So what is happening over here is you are defining a constructor, which I would be explaining after this, and then you are kind of assigning the values to this particular object's attributes. So these are the attributes as explained earlier that the variables which we are defining are your attributes. So like all the name, age and everything else is known as attributes or properties and like it is the term which we are using to define all the properties which is there to that particular object. So the property over here is name. So I'm just like defining, adding on the attribute value over here via this particular invocation. And now like let me show you if you want to like call on to a method, let's say. So over here I'm calling to the sing function and then so I have a song over here. So that is just the name of the song which I'm passing. So if I run it now, so it's like I'm using a format term. I'll explain this also. So like this is giving me an output of the function over here, which is blue one sings happy. So what this statement is doing, so these two, if you remember the formatting part which was done in the first class, so I'm defining the value of the variable over here and I'm in the string part, I'm just adding it as brackets. So after this part, when I'm writing format and then self dot name and song, it defines that in this particular bracket, you are supposed to type on the name of the object which you're calling. So it will write the output as blue one. And then when I say this particular bracket, over here, I want to give the output as the song which I'm giving as an input. So the output which I get is happy. So this is how this statement is being formed. So, yeah. So via this example, we can see that we are creating an object blue, and then we are defining the name and age of that particular object, and then we are showing that it has some function which is singing. So what blue is doing, blue is singing happy. So as you can see, this is kind of defining a particular parrot which is named as blue and has a name as blue one and is like good at singing and is singing happy song. So this is it. Now moving on to constructor. But constructor, as I said earlier, it is a special method. You can think of it as a function which is like defined or invoked as soon as you define an object. So what happens is over here, I'm not writing, like I'm writing person and then I'm passing on the values. So you can see that person is a class, but then we are passing on values. So what is happening is this init function is a constructor which is seen in Java and in C++C. So this is a normal constructor, but it is defined this way. And what constructor does is, as soon as you define an object, right, it will be invoked. So whatever you are defining inside the constructor would be the first thing which will be run via the interpreter or compiler in runtime. So what we are doing is we are passing on the values from here, and then we are invoking this particular constructor. So via saying person and then bracket ke under these values, we kind of are calling to this function. So a constructor has the same name as the class name. So as soon as we write person and then bracket ke under these values, the interpreter automatically knows that we are pointing to this particular function, which is init function. And then inside the init function, we are passing on a self value, which kind of defines that inside the class, I am pointing to this particular object, which has the name as my name. And then I am adding on the first name and last name as the passing values, which I later on define the name as self.first has the name Dipanshu and self.last has the name as Bala. So if I print my name dot last, you can see that I get the output as Bala. So now let's make another person over here. So adding on to another person, I will just say object as me, and then I would be adding in my name over here, and then I would be adding in the last name. So what happens is if I print over here me, right? So the output would be Joshi for this particular thing because like from here you can understand that what is happening is when I say self, so firstly it was pointing to my name, next time it is pointing to me. So different object won't be getting different values, like will be getting different values, and there won't be any error key my name ka last name was not Joshi, it was Bala, because from self we are kind of pointing out to this particular object when we initially define the values of the particular object via constructor. So self is used for pointing out the object which we are currently using to call the particular function. So moving on to what variable is. So variables are all the attributes or the properties or normal variables which are defined inside your class. So basically what variables represents inside a class is your attributes, like the values which are defined to the particular object, which defines a particular object is what variable inside class means. So over here you have growth as a class variable, then these are instant variables. So what is the difference between class variable and instant variable is class variable would remain a constant for all the values of different objects which you are defining. So let's say that I am defining a company, my company, and I want to showcase that the company has a growth, like each employee has a growth of 0.1 value throughout the year of the revenue which they are getting. So this is kind of constant value for everyone. So I won't be defining it inside an instant value variable because it is constant for each and every object which you would be defining later on. So that is what class variable is. It is something which is similar to all the objects which you would be defining, and you know the value already. So you define it differently over here. And then the instant value, which is like each and every object would be having a different name. Obviously, like every person in your company would be having a different name, or the company will be having a particular name. So we just add on that particular thing inside a variable, instant variable, defining that each object would be having a different name, different revenue, and different number of employees. So instant variables are only like are the properties which are different for each and every objects which you would be creating. So all the instance variables are inside, are defined and assigned inside your init function, which is your constructor. So all the values which you are giving to different objects are defined inside your constructor, which is your init function. So moving on to inheritance. So as I said, OOP is a programming paradigm, right? It was created so that we can like represent all the real life scenarios into your software language, like while you're coding it up. So we have some kind of special terms in OOPs. One of them is inheritance. So inheritance is similar to how we inherit from our parents, or like how we actually know inheritance. It is similar to that only. So over here, what we do is we have two different classes. So one would be, let's say, parent class, and one would be, let's say, child class. So what is happening is child class would be inheriting some of the functions or some of the attributes from the parent class. So this is similar to how we inherit, let's say, revenue, or let's say genes and all from our parents. So that is what inheritance is in object-oriented programming. You get some attributes, all the attributes depending on how the need is, from the parent class to the child class. So over this example, I'm defining a parent class as bird, and then in the bird, I'm defining a child class as penguin. So what is happening is bird is my parent class, and penguin will have some attributes which are common from the bird class. So over here, I'm defining some of the functionalities in the bird. So one is init, which is like just a constructor, wherein I'm just saying that the bird is ready, because till the time you kind of don't invoke, you don't create your object, that object won't exist. So I'm just like saying bird is ready over here. And then I'm doing who is this. So I'm printing bird, and then swim. So this is just like print statement. It doesn't like it is just there, just defining a function. So moving on to child class, I am defining a class penguin, and then I'm inheriting the values from child bird. So you write it inside your brackets, the class from which you are inheriting the values from. So this is the name of this particular class, which is penguin, and our parent class is bird. So that is over here. So inside this, I am defining that inside the constructor, I'm defining that the penguin is ready, because whenever we create an object of a penguin class, it would be a penguin, obviously. But when we create object from bird class, it can be any bird. So I'm writing bird is ready. Over here, I'm writing penguin is ready. And then who is this? So what kind of bird is it? I'm defining penguin. And then I'm defining a function run. So over here, I haven't defined the function swim, which was defined inside bird class. But then as you see, I'm later on accessing to it. I would be explaining what this is. So inside this child class, I'm defining a function run, and I'm just saying run faster. So after defining of the class, now I am creating an object, which is Peggy equals penguin. So what I'm doing is I'm creating an object Peggy of the class penguin. So all the functionalities and attributes of the class penguin would be added to this particular object, which is Peggy. And now what I'm doing is I'm using who is this. So as you see, I'm getting the output as penguin is ready. Okay, sorry. One second. So over this particular constructor, I have defined super.init. So what this does is, super is a keyword in Python which kinds of helps you like point to what your parent class constructor is. So super will point to parent class constructor, which is this. And from that, sorry, super will just point to this particular class, which is bird. And inside that particular class, I am pointing to the function init. So which is this. So as soon as I write Peggy is equal to penguin, so the first thing which we know is it will invoke the constructor function, which is your init. And then inside the init function, the first thing which we are doing is we are calling to the super function ka init. So that is this. So the first thing which prints is bird is ready. And then we are printing penguin is ready. So we get the output as penguin is ready. And then I'm using who is this. So the output directly is penguin, and then I'm using peggy.swim. So swim wasn't a function which was defined in penguin class. It was defined in bird class. Because as you can see that we kind of inherited the values from bird class, we are directly able to access this particular class, which is swim. Sorry, this particular function, which is inside the class bird, and I directly and I directly get the output as swim faster. Okay. So moving on to what, hopefully this is understood everyone. So moving on to encapsulation. So encapsulation is a property of object-oriented programming language. So what encapsulation represents is it kind of like the basic definition of encapsulation is wrapping up of data and unit into the wrapping up of data, attributes, and functionalities into one single unit. So whenever you kind of define a class, you are wrapping up all the functionalities, attributes inside that particular class. Uh, so that is what encapsulation means. Like from the definition itself, we can understand that we are just adding onto a block, adding onto a block wherein we are defining all the properties and data values and functionalities all together. So the class computer would be a wrapper to all these values. So whenever I define computer, it automatically says is that these all values are encapsulated together inside the class computer. So like you kind of understand this, right? Like when I define computer, right, I am saying that with computer I will get this particular function, this particular function, and this particular function, and this attribute. So I don't have to define it alag se. So this particular act as a wrapper to all the functionalities and attributes which are being defined inside the particular class. So in this example, what I'm doing is I am defining a class computer. Then I'm defining a constructor in which I'm defining the max value, max price as 900. And then I'm defining another function, which is a sell function, where I'm showing that the selling price is this much, which is again my max price. And then I'm setting a max price, which I would be like, which the user can define. And then I'm adding on to the value. And like over here, we are just defining what the max price is directly. So over here, you see that I am defining init inside double underscore. Then I have a underscore over here. So what this is, this defines your private values and your default values inside the class function. So to explain what I just said, what is happening is inside class we can have attributes and functions which are public to everyone. So if I like create another function altogether, sorry, another code altogether. So over here I have a class computer, and let's say I am saving this in my notepad, and then I'm creating another notepad wherein I would be calling this particular class, which is computer. So over that particular thing, which is not a part of my particular actual code, I may or may not be able to access these particular values. So if I am defining the value inside with this particular double underscore, what it means is that that particular term itself, this particular attribute is private to this particular class, and it is only visible inside this particular class. It won't be visible to a function which is calling from another code altogether or another subclass. To better explain this, let's take an example of a friend and a family. So inside family, let's say your father has a credit card. Okay. So the PIN of the credit card would be private to only your family members, or more particularly to your father. But then since you're inheriting that credit card, let's say he will give it to you later on. So you would be knowing that PIN. But then if you have a friend, let's say like you have a friend and that particular friend needs your credit card. First thing, he won't be knowing that you have a credit card unless and until you tell it to him. And if you do tell it to him, then you would be requiring to like give in the pin of the card to him. So that is something which we normally not do, and that is a private case. So inside a programming language, to define such particular scenarios wherein you want to define a attribute or a functionality as a private value, you don't want to share it with anyone else. For that, we kind of use this underscore, which kind of defines to the interpreter that this particular attribute or this particular function is only accessible to the first object which to the object which we are creating of that particular class. So over here, I'm not going into the depth like via showing that I am creating a friend class, and from the friend class I'm trying to access let's say max price. So over here, I'm not doing any such things, because for that you will like need to like code it up first and then understand it properly so that we can move on to more depth. And friend class is something which, unless and until you like kind of don't code it up, you do kind of don't code up the inheritance part and then you understand it properly and then you move on to a friend class, you won't be understanding this particular thing. So I'm not going into so much depth via defining a friend class and showing the example. So verbally, I'm explaining what exactly a friend class is. A friend class would be a class which I'm defining in, let's say, some other code itself. So this is one code, and let's say I create another Colab notebook and I have a code over there. And what I'm doing is I'm importing this particular class over there, and then I'm inheriting those values. So what is happening is that the class computer, and let's say I created another friend class which is laptop. So in laptop, some of the values can be inherited, but then you won't be adding in your model number from this particular object to that particular laptop. So the model number would be a private value for this particular class itself. So it won't be accessible to your laptop class. But then you can say that set max price, like the price as an attribute, can be common to computer as well as to laptop also. So that can be accessible to both of them. So this is what private, public, and default is. And like this is like it is a kind of property which is available inside encapsulation, wherein we kind of define private, public, and protected values. So this particular terminology underscore is used to define a private value. And when we don't add on underscore, right? So like over here, when I was defining year, so this particular value is your public value, and you can directly access it over here, and you can like access it through your friend class also. But then these private values which we are defining via using underscore will be only accessible to your objects and the inherited value if you're defining it that way. So if I run this particular code, you can see that initially I am like calling c.cell. So I get the value as 9,000. Then I'm setting up the max price as 1,000, which is over here. And then if I do c.cell again, okay. So what is happening? The value won't change because this particular max price is a private attribute which is only available inside your class function. So to access this outside your class, like outside your class, you won't be able to do that unless and until you call it through a function. So what is happening is C is an object. But then while I'm trying to showcase it to you directly via using this particular attribute value, like underscore max price, and I'm trying to change the value, that won't be happening, because like as you can see, the C dot cell give me an output as 900. But then over here, initially in the first example, wherein I defined year is equal to 2016, I was able to get the value as 2016. And if I do this, okay, and if I print carbon dot year, okay, so over here you can see that I was able to change the value directly because this is a public value. So via defining a private value, which is via using this underscore, you can see that the value is not accessible or is not changeable directly. But when I use a function, which is like set max price is my function, wherein I'm defining cell dot max price as price. So price is the value which I'm passing over here. And then if I try to check the value of max price, I'm able to see that the value has changed. So what is happening over here is that the private attribute is only accessible when the object uses a particular function to add on the to change the value. So publicly you won't be able to change the value, but then via using the functions which you know. So let's say if you know the pin, so to access the pin, it is only inside your brain, like from the credit card details. The password is only inside your brain, and you know the pin. You know the password for that particular card. But then if you want to change that particular card ka pin, what you need to do is you need to go to the website, and then you like kind of define that you are this person who is doing the changes, and then you're able to change the pin. You are not able to change the pin directly. So for and like this is a similar scenario wherein we are using a function to access the class attribute which we defined, which is a private attribute, and then change the values. Hopefully this is understood. Moving on to polymorphism. So, okay. So polymorphism is again an ability in OOP, which is derived from a Greek word, wherein poly means many and morphism means form. So what exactly polymorphism defines in your software programming language or in Python is that defining different kind of methods or different kind of attributes which kind of like has the same name but then would be having different functionalities. So to give you a brief example of what this is, let's say you're defining you want to define area of different kinds of shapes, like say circle, rectangle, triangle, and pentagon. Like just take these four as the shapes which are available. So if you define a class shape and then you define a function area, so for all the different kind of objects which are just like named, which is circle, square, triangle, and pentagon, the area formula is different for each one of them, and each one of them would be having different kind of attributes. Which is for circle you would be having a radius, for square you would be having length and breadth, so on and so forth. So inside the class shape, what you can define is the attribute saying that area is your attribute. But the area attribute, which is same name for each and every object, would be having different functionality altogether. So in shape, inside the shape, when you define an area function for circle, let's say, so for circle, the area functionality would be doing is pi r square. For square, it would be doing L square, which is because it is square, so L cross L. And majorly it will be L cross B, which is N cross breadth. For okay, circle. For a triangle, you can like go with your Heron's formula, which is root over S into S minus A, S minus B, S minus C. So that kind of give you the area for the triangle, and for pentagon you can go for pentagon ka area ka formula. So as we can see that each one of the area function is doing some different kind of functionality, but the name is same. We are keeping the name as area. So this is where polymorphism comes in OPs. Like this is the concept of polymorphism, which which I just defined, that I am defining same function name which is area, but then the function name is doing some different kind of functionalities and different kind of scenarios. So over here, this is a parrot and penguin example. So in this, what I'm doing is I'm defining a parrot class which has function fly and swim, and then I'm defining a penguin class which has a function fly and swim again. So parrot can't swim, but then parrot can fly. Penguin can't fly, but then penguin can swim. So I am creating a common interface which is def flying test, and I'm adding onto a bird. So over here I'm not defining. I'm just doing bird.fly, and then what I'm doing is I am creating an instant object for blue, the instant object for parrot, which is defined inside the name blue, which is your object, and blue will have functionality fly, as it can fly but then it can't swim, and Peggy will have the functionalities as it can't fly but it can swim. So when I'm doing fly test blue, fly test Peggy, what I'm doing is I'm calling this particular function and then I'm saying bird.fly. So over here, you're seeing that the name fly is common for both the objects, but then it has different functionality. So this kind of represents what polymorphism is. So if I run this, you will see that in first case, we are getting parrot can fly because inside this particular function, which is for parrot, I defined fly as parrot can fly. And for penguin, I defined it as penguin can't fly. So now the question comes is, how does interpreter actually understands that we are calling this particular fly and this particular fly in this scenario and this scenario? So what is happening is I am passing on blue, which is an object of class parrot. So through self, which is my attribute, I am able to understand that when I pass on blue over here and then I'm doing blue.fly, it understands that I am calling fly, which is a function of class parrot, and it is pointing out, like the self would be pointing out to this particular object, and directly I will get the answer as this. In the next case, wherein I have penguin and Peggy as the object, so we know that Peggy is a object of class penguin. So when I do Peggy.fly, through self function, it will understand that currently I am pointing to the function, the object of class penguin, and the class penguin, inside class penguin, I'm calling the function fly. So directly it will give me this output. So over here, you can see how polymorphism is like kind of shown. It is shown via adding on to the same name, which is fly, and then different attributes. So self, if you see over here, self is like, it looks same, but then what over here self is doing is for this particular attribute, self would be pointing out to an object which is of class parrot. Over here, self would be pointing out to an object which is of class penguin. So accordingly, we differentiate. So whenever you are kind of using polymorphism, right, you will come across terms as function overloading, method overloading, or function overriding. So over there, what is happening is, what do you mean by overloading is you do this, like I have same function name, but then different attribute. So over here, my attribute is of type class parrot. Over here, my attribute is of type class penguin. So through this, I am kind of differentiating and overloading the same function, which is fly. Yeah, so that is what function overloading means, like defining the same, again it is a type of polymorphism only. So what you're doing is you're defining the same name but then different attributes type, and accordingly you're able to understand ki ye wale ko bulana hai. The other thing is, which is function overriding, that you will come across in like when you like actually study this properly and in depth. So in that case, what happens is you have something known as virtual class, abstract class, and so on so forth. Like there are many different terms. So what happens over there is you define, let's say you just define uh, a function this way. You define the function this way: def fly pass. So what is happening is you define the function, you're gonna use it later on, but then you haven't defined what the functionality is. So later on, when I do this def fly, and then I define all the values, or more like to give a like, proper example, when I do this def fly and then function name, and then I'm defining, this is what I'm doing over here. So what I'm doing is initially defined fly values jo tha, like I have nothing over here. I am kind of overriding that value, overriding the whole process via doing this. So that is an example of function overriding. So, polymorphism can be seen in many more places as object overriding and so on and so forth. That you can like you can. I will share. I would be sharing up some more resources. So from those resources, if you are interested in going into actual depth and understanding ki how exactly overriding, overloading, and object overloading, function overloading works, you can cross through those resources, which I would be sharing later on. And if you have any doubts, I would be there to help you out with that. So with this, I am done from my side for classes and objects. So if you have any doubts, you can ask on the Q&A session. Okay. So we have some notes. One is, why are we writing self as a parameter? Can we keep it blank? Okay. So Varsha, we can't do that because in Python, it is mandatory to define, you are supposed to write self inside a class function. It is, you can't keep it blank. I'm explaining why. Because when I define this class car and then I define uh, over here, I'm not passing anything, I'm just passing a object. So our shelf is kind of defining that I am passing this object as a whole, and then from that object I'm getting the value speed. So self kind of points to this particular object. So if I do this right, the function won't know which object I'm currently pointing to. So for that, we write self inside the function. Okay. I hope that answers your question. So the next question, which is asked by Avril, I hope I'm pronouncing the name correct. So the question is, can you explain this use of super function again? Okay, okay. So what super function exactly is, I'll explain it through here. So super is a function. Uh, it's actually a keyword and a function. So what super is used for is, super is used for calling your parent class. So whenever I write super, right, it kind of understands that I'm calling this whole class itself. So as you can see in inheritance, what I did was I am creating a child class of class bird. So bird is a superclass or a parent class for this particular class, which is penguin. So how do you call your parent class functions from this child class? So more like, how will you call like in real life scenario, how would you be calling to your mom and dad? Let's say you want to like contact them up and you want to ask them for something, you want to ask them for money, or let's say you want to get food or something, like so on and so forth. You want to eat something and you want to just call them up and just let them know that you are hungry, so like they need to cook and all. So for that we use mobile phone, and then we just call them up, or we just like say, mom meko ye chahiye, dad meko ye chahiye. So similarly, for a child class, which is penguin in this scenario, we need to call the parent class or super class, which is bird. So for that case, we use super as a function. So what super function does is, it will just help you call the class bird, and from class bird we are using the function which is init, which is more like the constructor of the class bird. Hopefully that answers your question. Okay. Any more doubts? Okay. So I would be sharing on the resources later on, and like either you would be getting them through your mails or through Discord or some other channel. You would be getting those. I also have a additional what to say bonus notebook, which kind of has all the in-depth functionalities of whatever we have learned till now. So for the function like print. So I initially said that print is a function, right? So I have defined what exactly print function has as its attributes and all, and that would be there in your bonus notebook. So that I would be sharing it to you later on. And if you have any more doubts based on those notebooks or based on all this stuff, you can ask that. So for
Guys, just stay tuned. The recordings for each of this session will be put on YouTube. You can find the links for the YouTube videos in the event page. So if you see the same event page where you joined the event from, you will find the YouTube links after we end this session. So you can watch your YouTube videos there. Also, we'll be putting the same links on the WhatsApp groups. We'll be just sharing those YouTube links on the WhatsApp